So hi everybody, I'll do the introduction. I'm Mario from Microsoft, here with my colleagues, Janice and Ambrogio. We're going to talk about insurance. Telematics insurance exists since forever, but it hasn't worked as well as expected, let's say that. And now that we have software-defined vehicle and the EU Data Act, there are new possibilities to be able to go into this direction. But of course, always having the idea of respecting privacy and user choice. So before we get started, I just want to indicate that at the end, the main goal of all of these topics is to reduce accidents because everybody wants to get home at the end of the day. So let's get started.
Yeah, all right. Insurance. Now after hearing something about processes, now insurance, I hope you're not questioning your life choices already. But
Here.
oh yeah, thank you. Yeah, let's maybe talk a bit about our motivation. I mean, currently, basically the only connection between insurance and vehicle is maybe the VIN on the contract. And we want to change that. And there are a lot of good reasons for that, why we as an insurance are interested in vehicle data. And I think the most obvious one is everything related to pricing. I think you know some pricing use cases driven by in-vehicle data. I think one of the most simple one is a simple pay-as-you-drive use case or pay per kilometer, pay per mile use case. That's nothing really special, but it requires in-vehicle data to at least to run it kind of integrated and smooth. And another use case that is maybe more relevant is the pay-how-you-drive use case. So using in-vehicle data to, well, as an insurance, being able to better evaluate the risk of the driver. And then if you think a step further, we can also be able to better evaluate the risk of the vehicle itself by any safety relevant features that are in the car, for example, ADAS systems. Or if you think one step further, the autopilot or autonomous driving. As an insurance, it's kind of crucial to know who did what at which time. So it's also some kind of product liability versus driver liability. And for all these questions, the only way to go is with in-vehicle data. Another point, everything related to sales. So the term embedded insurance is used quite often and basically all the time means only the product perspective of it. So the insurance product being kind of tagged to the vehicle or something. But you can also think about it from the process perspective. So imagine being able to do everything related to your insurance out of the car without any need of any external, I don't know, contact, phone numbers, emails, or whatever. That's also maybe a goal to be able to achieve when the insurance and the vehicle come closer together. Another approach on the sales channel is, well, let's call it the what you drive, the situational insurance. So to be able to detect specific events maybe which are not covered by the current policy. So I don't know, when you are driving with a trailer or when you are leaving the country, to be able to add additional coverage to your current coverage to specific situations. So it's more like an upselling perspective, if you want to tell it that way. And of course, when it comes to insurance, another really important part is everything related to claim services. So basically supporting the whole claim journey from automated first notification of loss to using in-vehicle data or sensors to evaluate the damage and then to support everything afterwards, like the workshop communication and everything that comes with it. I think these are the major use cases for us as an insurance, why we are really interested in working with in-vehicle data. So what are the challenges as of today? Well, one thing might be not that that big of a deal, the large amounts of data. But if you think about it, I mean, we have 100,000 of cars in our portfolio, and collecting dozens of sensors with multiple hertz frequency for every trip, it sure is possible, but it's expensive. And we also always have to ask ourselves, is it worth it? So is the information we get out of it, is it more worth than what we pay for collecting this data? And that's basically the current approach. It's the typical big data approach: collect first, analyze later. Yeah. The other topics are, I think, described best as lack of standardization. So currently, every manufacturer does their own thing. Well, first of all, on the data side, as an insurance, it is very important for us to be able to harmonize the data across our whole portfolio. So we, in order to identify some risk relevant events or something, we have to be able to detect them across all our fleet. So not only one manufacturer, across all of them. And that's sometimes an issue today. And another thing is everything related to, first of all, of course, infrastructure and architecture, which is also not standardized in any way, but also the whole compliance and data protection and all these problems. It's also a thing that you basically need to start from scratch every time you talk to a new manufacturer. And that all results in currently in very high costs, which we need to tackle somehow. And that's basically why we are here. So first, by coming with an event-driven approach, so not using all the in-vehicle data, but defining specific risk-relevant events and only detect the data when these events occur, but you will tell about it a little bit more later. But also to have some kind of standardized on both the infrastructure and the compliance level. And yeah, I think that's it. How does it work?
Yes. So let me just take the next part. And it's good that we have a couple of colleagues here that I hope that you have the chance to meet. One is my colleague from Data Spaces. Where is? Data Spaces, yes, there. My colleague from Mobility Data Spaces. So there's two different things. Now, I don't want to talk about SDV because we will hear it today to extortion. What I want to talk a little bit is about why these data spaces and EU Data Act. So we have the EU Data Act that describes how to exchange data between companies at a very high level. Then we have how is this done, which is the definition of the technical standards. And there are two organizations that do that, the International Data Spaces Association and Gaia-X. And the third aspect, which is Eclipse, is how do you actually do it? And one implementation is the Eclipse data spaces implementation, data space components, implementation. So these are the foundational blocks of how you share data. And then is what are the data space authorities that enable you to exchange the data? The reason why I mentioned mobility data spaces is because it's first of all supported by the German government, as you can see, and the stakeholders are many of the OEMs, just to put it that way. So tomorrow we will have more discussions about that as part of the hands-on. And just to clarify super quick what is data spaces, again, we will see it tomorrow, is today the traditional approach is to use a centralized marketplace to share data, but it has any number of troubles, and especially the main problem is that the OEM loses control of the data, which is not acceptable. So the idea of a data space is, instead of doing that, you have a decentralized network, and all of the exchange happens peer-to-peer, and is with full autonomy. So You have a catalog where you can describe what kind of offers you have. And this is going to be, it's a multi-cloud federation, also from my colleagues from Amazon that may or may not be here. So that's important because as Kai mentioned, it would be awesome if we had everything on Azure, but it's not gonna happen. So hence, it has to be important to do it that way. And that being said, let me just move super quickly to what is the insurance blueprint. So we want to build an end-to-end demonstration of how these kind of solutions work. So that means 3 components. On the left side, SDV. No surprises there. So what we want to showcase is how do you use SDV projects to collect data that makes it relevant for insurance. The second part, which is super interesting also, is the telematics platform. As my colleagues from Baltic Mobility were talking, this is a very important topic. And what we want to describe here is not so much the telematics platform itself, which is a pain, but rather that is how do you process the data that you get from the vehicle in order to create data products. And the third aspect that we want to address is then, how do you use data spaces to do the actual sharing of the data, respecting, again, user privacy and user choice. So I won't go into details because that's for what tomorrow is for, but basically we're gonna cover 3 things. What does it mean in vehicle when using the orchestration blueprint? That will be the number 1 part of the presentation tomorrow. The second part will be, what does it mean from the telemetry platform from the point of view of data processing? That will be the second part for the workshop tomorrow again. And the third one, and here my colleagues from Mobility Data Spaces will go into details, what does it mean to share data using a data space? So these will be the 3 components of the workshop tomorrow. So slowly, we are approaching the end of my time. Ambrogio, he's going to explain a little bit about what we are doing with the actual events.
Okay. Oh. Yeah, as Yannis already mentioned, we, as insurer, we don't need the whole raw telematic data. We only need insights into the driving behavior. And so to get these insights, which enables us to assess the risk associated with the vehicle. Ja, oh, sorry, ich fühle mich nicht gut. Ich fühle mich nicht gut.
Soll ich übernehmen?
Ja, das wäre nett.
Okay. Yeah, we had a long flight. We woke up this morning at 3 a.m. to come here from Hanover. Yeah, so I take over. Yeah, so as I mentioned earlier, these risk events, or the focus on risk events, have some major advantages. First of all, it reduces the amount of data we need to collect and to analyze afterwards. We can do some previous selection of what events, what data may be interesting for us for evaluating the risk. But also, maybe more importantly, it's about, first of all, compliance. Depending on how you read the Data Act, you need a purpose to collect data, especially for us as insurance, where the BaFin also looks at it. And it's not that simple. We have to meet certain regulatories, and we think that focusing on events might help us with that. And another point is, well, we are from HDI Germany, and especially in Germany, telematics products are, let's say, failed somehow. So they're not really popular. And I think one reason of that is because they are some kind of, or the driver get the feeling that they are some kind of over-observing the driver, and that they are not really transparent. So you basically get a score, and then you get some discount, and basically that's it. And by focusing on some risk events, like you can see here, we first hope to make it much more clearer for the customer on what is he actually paying for? What is he getting his discount for? And also for us to have some kind of to get some kind of a feeling which events are actually really having an impact on the risk. And well, these events can be quite simple, like speeding here. So I don't know, event speeding is driving above 130, 180 kilometers per hour, or everything related to the ADAS systems like TCS, ESC, etc. If it's active or not active, that's something that may have or may not have an impact on the risk. And you can also do some like more complex events. Harsh cornering is one example. You can also think about an event like driving on the highway, on the Autobahn, when you are having a constant speed above 100 kilometers per hour and not turning your wheel, for example. That are events that can help us to accomplish our goal regarding some kind of redefined telematics product, if you want to call it that way. Yeah.
This is for tomorrow, because we didn't implement every single potential insurance event. So the idea for the workshop tomorrow is we have some data recordings, which I will show you. We have the opportunity tomorrow to be hands-on and use all of the facilities that we have in Eclipse to contribute more. So the initial events, as you can see, are things that you already know. But the goal of SDV, of course, and the goal of Eclipse is that we can start creating some kind of code-first standardization around this. Okay? So here are some examples, because this is a blueprint contribution, so there is like honest-to-God code. It's not only PowerPoint. There is a lot of PowerPoint, but not only PowerPoint. So we have initial code that you can see here, which is the definition of a couple of events. Very simple ones, so they fit in the screen. One is the definition of speeding, when it starts, when it ends, and what data needs to be collected. And the same for the activation of the cruise control, when it starts, when it ends, and what data needs to be collected. So if you can see this, this is related to signals that come from the Covisa vehicle signal specification. So just to finish quickly, slowly, there is a demo, of course. The first, this screen is animated. This is the data that we use. So this was hash driving, as you can see. So I just took a sample data that we collected some time ago. We don't use the position. I only want to show you this so you see how it works. And then we implemented the first approach, which we use Eclipse and Kaios and orchestration blueprint. I have to press play. Okay, so we can run all of the different elements here, service registry, that is Chariot and iVeggie for the digital twin. So we started all of these different elements. Once that works, so we have all of the workloads, then we have a vehicle provider that uses the vehicle digital twin specification and the Covisa vehicle signal specification, the digital twin definition language and the vehicle signal specification, in order to register all of the different types of events that come from the vehicle. And last but not least, we took a recording, which was super simple. It was just a CSV file with all of these signals. We run it through our detection algorithm in order to detect all of the events here. I just run it quickly, so you can detect all of the events that are included in this driving. So I know the person who actually drove for this test, and I think the passenger that was doing the recordings almost threw up on this. It wasn't fun. You can see lots of hash braking and acceleration. I have some nice diagrams if you want to see them tomorrow about the feeling in the body. Anyways, we're about to be finished. Just next steps. This is very early steps, to be clear. So we are just starting to explore the possibilities that something like SDV brings to the table and the possibility to access the data directly from the vehicle. So we want to work with the community, of course, in order to define this type of risk events and understand what they mean, one. The second part that we want to collaborate is a better integration with the vehicle data, because we only use a CSV file we would like to use one of the projects, for example, ECAL, which is to play these kind of recordings and eventually integrate them directly to the vehicle. The third one is with the SDV part, we have an implementation. So we want to have a better implementation, for example, leveraging the fleet management blueprint in order to send this type of events to the cloud. So we have the processing. And last is we want to have a complete integration with data spaces to showcase how the data sharing works. So I hope that you have time tomorrow to join our presentation. We have some data available. The project is there, so you can take a look to the latest state. Unfortunately, I cannot check in the data because I'm not allowed to. But I can, of course, but I can provide you a couple of sample data files tomorrow if you want to try it by yourselves. Okay, thank you.
Thank you. Well, that's extremely cool, extremely interesting, and brings together more than one Eclipse working group. And of course, it's one of the blueprints, so it's fantastic. And that's a great showcase of collaboration, even outside of the working group. So, any question? Yes.
Thank you. In one of your early slides, you showed an overview of the architecture, and there was a ring buffer, if I'm not mistaken.
That's right.
Can you elaborate a little on what that does?
Yes, because when we detect a risk event, what we would like to collect is not only something happened, but also understand a little bit of the signals. A certain number of, I didn't explain it properly. You detect the event, and you also collect signals before and after the event as part of the analysis. But of course, which signals you collect are part of the definition of the event. So, for example, if it's a speeding event, probably you don't have to collect anything additional. But if you have a hash breaking, you do want to collect additional signals because you want to be able to differentiate between do you do hash breaking because you just like driving like crazy or because there was a dog in front of you? No? And of course, penalizing people because they are driving over dogs is a bad idea from the insurance point of view. So that's why we need to collect additional data.
So it's kind of a sliding window, if you will, over
Exactly.
the data? Oh,
Exactly,
okay,
exactly.
Yeah, I think we would take a closer look at it tomorrow to explain it better. But what you also can think about is what we basically would need for every event is the odometer value, so the driven kilometers. Especially if you think about an pay-as-you-drive tariff, then you maybe get your kilometer price and get a discount on the kilometer price. So in order to know the risk per kilometer, you need to know, like for example, on how many kilometers of the trip you drove with ADAS System X on. And yeah, that's where, but I mean, you can put in there any data you want to. If you want to prove some specific idea, put in the data and check if you can get any more insights out of it.
In a follow-up, the data that you send to the backend, that is not VSS data, that is the event that you derive from the situation, right? The occurrence of the event, basically.
That's correct. And okay. we have to mention three things because I talk about data privacy and consent, and this is super important. When we are thinking about the data that we sent is, the vehicle has the possibility to collect the data, but it doesn't mean that it will. If it's authorized, it will. I will sell it to the telematic platform of the OEM. And the OEM is the one that, if it's authorized to send the data to the insurance company because they have a contract and the driver set a contract, then they create a data product, and that's the kind of data that gets exchanged between the two companies.
So in the FMS blueprint, what we try to do is collect the VSS data, then reduce the amount of data by filtering out the irrelevant data points. Mm-hmm. But still, we are sending the VSS data into the backend, into a telemetry backend.
We're doing the same, yes. We have to discuss tomorrow or later today.
And just a quick question. So what we are struggling with as well is that once we have the data in the back end, how do we share the data actually? And that is where the data spaces come into place, right?
That's correct. And I would love to have a conversation later with a cup of coffee. And maybe later with beer. It's even better.
Okay. Okay, thanks.
Thank you.
So we are like 4 minutes late, but one just quick question. Yeah.
We have 16 seconds left. 15, 14. So hurry on.
You know what counts? What I say. So.
Thank you, Mario, Yanis, and Ambrogio. I wanted to have a short question on the Covisa interaction because the Covisa VSS specifies the semantics of the data. What do you use as a protocol for communication then to the fleet management backend or to the telemetrics backend?
Right now, nothing, because that's the part that we want to implement next.
Okay, you got lucky. The question was really fast. So any other one? Yeah, I'm going to come to you. And then we go for the coffee break.
I was just wondering, are you looking to quantify the events as well? So if you are doing harsh break-ins, or how harsh is it? Because if you only set a threshold, then everything above that threshold will be harsh break-in. But if you are twice over the threshold or 10 times over the threshold, it will be maybe interesting to the insurance companies if, like, how.
Yeah, I mean, I think that's also what this event data is for. So I think the first approach would be to set the boundaries quite low. For example, speeding, set speeding to 100 kilometers per hour, which is not quite fast, but you can start with that. And if you get this, collect even more data and maybe shrink the window down to the threshold at which point it's becoming risk relevant. And I think, yeah, that's basically what the event data is for, to be able to look at the event more in detail afterwards.
Many of the evaluation of how hard or how risky the event is will happen in the cloud, not in the car.
So it is being considered, or will be considered as well?
Yes, definitely.
Thank you.
Okay, so it's time to take a break. Thank you. Thanks a lot for that. Tomorrow we're going to have like a entire morning workshop. So thanks a lot.